Hello, and how are you? Welcome to our second lecture, first session. We're going to resume from how we stopped in the previous lecture. In the previous lecture, we stopped at the decision making, and I also remember answering your questions when you asked about the difference between dynamic variables and how dynamic variable is different from other kinds of variables, and I demonstrated using this, telling you that a dynamic variable can be able to record any kind of data, where a specific variable like integers, they'll record some specific kind of data. So as we proceed, you will see the actual need why we need dynamic variables. So just understand that they are there and understand what they possibly do. But as we proceed, we will start implementing and see the real meaning of dynamic variables. So without wasting much time, let's go straight into today's business. We're going to look at lists. So in that programming, lists help us to do what? To store variables of same data type into one specific location. So we can iterate through that in order to do what? To have our data organized in that one particular place, as just the way it sounds, a list. So these lists are very important. We can use them to store related data, and just look at your phone. Everything is a list. Your WhatsApp messages are lists, where you have unread messages that are stored in a list. When you open a chat, it is a list of messages between you and the person you're chatting with. So everything that you do, phone book is a list, everything, the calls are a list, almost everything that you do, it is a what? It is a list. So list becomes very handy. So I would like all of us to be very attentive so you can understand how to implement these lists. So these are some few notes about the lists. It has elements. It starts from, we can access it using the different points of a list can be accessed using what? Using a value called index, which can start from 0, which always start from 0 up to the end of that list. So we have a fixed list and a growable list. We're going to look at these ones. So if we say this variable list, if we declare a list in this way, this list will be what? Will be growable. It can be changed. And then this is another way. This is also another way of initializing a list. And we're going to look at the demonstration of how we can do what? How we can implement lists. So this is an example. So we're going to go into practicals after these notes, and you see how we can implement these lists. So with that much said, let's go straight into lists, and we see how we can make use of lists. So what I'll do, so of course lists come after looping, because to iterate through the list you have to what? To loop. So in the previous lecture, we looked even at what? At looping. So let me go ahead and create a new file. So I'll come here and say, create new file. I'm going to declare it as file number 9.lists.dat. All right. So you know why you're putting that. You know why we are putting these numbers. So let me go ahead and create my main function. You know the reason why we need the main function. So I'll put here my comment and say example of a list. All right, so I'll show you how you can define a list. So you can define a list of a specific variables. Like I'll say a list, and then you specify like this. So you put a less than sign and a greater than sign to specify, and then you give this list a name, and then you declare it like this one. Okay. So by doing so, you'll have a what? A list of numbers. So you can dump these numbers by saying print numbers. So you'll be able to do what? To see a list. So let's go ahead and run this file. So still remember to run the file, just simply write that and then the name of the file. So I'll put 9 dot like this. So it will be able to show me the list. So you see here we're able to store these different values into one variable, and that's what we call a list. So this list has so many things that you can do with it. So it comes with different with different functions that we can use to manipulate it or to make use of the list. So for example, I can go ahead. So this is a list before adding as a new number, but I can go ahead. So this is a list of a name. This is a list of a name. You can print it like that. And then this is a list of dynamic things. So a list of dynamic values, it can be able to do what? To store dynamic data types. So you can also declare a list like this by just simply saying a list of what? Of 5 numbers. So it will go ahead and do what? And declare for you 5 numbers. So I can go ahead. That's a static list, the one that will be specific like that. So let's go ahead and demo different functions of what? Of list. Different functions of a list. So the first function, to add an element in a list, you just simply say list.what.add. So I can just simply come and say this list.what.add 6. So by doing like this, it will add 6 in this what? In this particular list. And we can be able to display like this. So let me go ahead and run this file. So if I do like this, so let's explain and see what we've got. So it's a list of strings. This is a list of what? Of dynamic values. Now this is our list number 1, the very first list, this one here, where after we have added what? After we've added number 6. So that's how you can append an item into what? Into a list by just simply saying list.what.add. So we can remove an item from the list by saying list.remove. So if you say list.remove, it will go ahead and remove an item from a what? From a specific position of a what? Of a list. So by doing like this, it will go ahead. For example, let me say I want to remove the what? The second, the third. All right. So let's say that I want to remove. Okay. Let's say I want to remove this number 2. So I want you to think. If I say list of numbers that remove 2. You know this list you're having 1, 2, 3, 4, 5. So I want you to ask yourself, which number is going to be removed from what? From our list. So as we discussed, we said that the list always starts from what? From 0. So it means that's going to remove number what? Number 3. So it's going to begin from here, 0, 1, 2. So the list that we are going to print here, the very last list, is going to be missing what? It shall be missing number 3. Why? I mean, it will be missing number what? Number 2, because it is in the position of what? In position of 2. So there are different things that you can also participate in the list. So this is removing number 2 in the list. So if you have like 2s in the list, it will go ahead and do what? And remove them. So that is remove. So if we say remove at, so remove at, it will go ahead and remove the element in the position number 2. So this one will remove all elements that are equal to 2. So let's say that we have maybe here another 2, right? Let's say that we have here another 2, another 2, another 2, like this. So this remove will go ahead and remove. Let me first comment this one. So if you say that remove 2, it will go ahead and remove all the 2s. So you'll see that the 2s will be what? Will be removed. So if you say remove at 2, so it go ahead and remove those specific what? Those specific numbers at 2. So that is the difference between what? Between these remove and remove at. So if I go ahead and run, you see that the item that was in position 2 has been what? It has been removed. So that is what? That's how we operate list. So list has got so many functions. So you can go ahead and read the documentation of that after you've got the concept that the lists exist, and it can help you. They help you to store multiple variables in the same, multiple values in the same variable. So you can go ahead and read much more about the list. So let me show you the most useful functions that you can use on a list. We have first. So first will give you the first element in a list. We have is empty. So is empty will tell you whether a list is empty or it's not what? It's not empty. So we have is not empty. Is not empty will return true if the list is what? Is not empty, if the list contains something. Then you have length. This one will return the number, the length of the list. Then we have last. This one will return the last value of the list. We have reversed. Reversed will go ahead and sort the list in a reversed order. And then we have single to get a single element from what? From a list. So there are so many variables. So many functions that you can learn about lists. So I just recommend you to go ahead and read the documentation and understand multiple things multiple functions that you can make use of that you can implement on a list. However, we should just know that lists exist and they help us to keep data into a single variable, multiple values into a single variable, and they are very, very important. Almost you cannot create a meaningful program that does not have a list in it. So we proceed. So here in details, we give you the details about about the list. For example, .add. So this add will add a value as we discussed on a list, and then you have removing add. It will remove values from from the list. So let's go ahead and look at a map. So a map is also another important another important data type in that programming. It helps us to keep our data in a structure of a key and a value. So we can specify and say, okay, if we have students, a student has a name and maybe gender and maybe age. So those are three values about one particular student, but you can have like many students. So if you want to keep these values, if you want to keep this data of student in one structured way, you can use what we call a map. So you can just use a key, and then inside the key you store a value. So this value can be of a different data type as we're going to look at. So these maps are also very important in a way that they're the one that enables us to work with APIs and also be able to work with different programming languages like JSON when we are doing through JSON when we are creating our mobile applications. So to get you back on the point, we have looked at the list. The list will keep multiple values in one variable. A map will keep data of a certain structure in a variable, and it will keep it in a form of in form of a key and a value, whereby we use a key to access the value in a certain position. So let's proceed. So this is how you declare a map. We're going to practically demonstrate it. You just simply say a key, maybe if you can say a name, and then you go ahead and put the value, and then you specify another key and then put the value. So you can loop through, you can access this map through and also manipulate it through their respective keys, the value in the map through their respective keys. So declaring a map is very simple. You can just use this. This is one way, by just simply saying a map equals to a new map or map new. By doing like that, will get you it will go ahead and declare for you a map. Or you can just simply declare map directly by use of by use of curly brackets. So let's go ahead and demonstrate the maps. So I'll come here and say new file and put number 10. You know why we are numbering this, and then you can say map.dat, or you can say maps.dat. So let's go ahead and create our main function. All right. So let's create an example of a map. So we can say our map is going to be, so let me explain this again step by step. So you can say my map is going to be having a specific structure. Okay, this is one way. However, I can define it in this way. You can say my map is going to have a specific structure of a string and a string. So a key will be a string, and then you can put comma and then say the values will always be a string. So what does it mean? It means that this map is going to be accepting It's going to be accepting strings only. So if you put here dynamic, it means that it's going to be accepting to store strings only. If you put here dynamic, it means that this map can be able to even store the dynamic data. So I can just simply say product. So for example, here I say product, and then this is the name of a variable, and then you say equal to, and then we declare the product like this. So to declare product, we just simply say equals to, and then you open curly bracket, and then you put the string, which is a key, and then put colon, and then the value of that key. So put there the string and then the key. The key and the value, the key and the value, like this. So I can go ahead and add, for example, this data type. So here the point is, we are having this product in this particular structure, all right, in this particular structure. But this structure is able to do what? To store this data in what? Is able to store these different types of data in what? In the same variable. And I've told you that we can access this data by the use of what? By the use of a key. So I can say, for example, here, display product details, like this. So I can just simply go ahead and say print. So let's go ahead and put, for example, the product name. Okay, product name is going to be the $, and then you put product, and then you specify the value like that. So it means that there we shall be accessing the name key in the what? In our map. So I can go ahead and display the product name. I go ahead and display the price. I display the what? The color, and tell if is available or not. All right, and print is availability. So like that. So if you try to access a value that has not been declared, it will give you a what? It will give you a null. So let's go ahead and display this. So if I come here and then just simply say dart, all right, dart, and then go ahead and put 10 dot the file name. If I press enter, you'll see that we're able to get the name, the price, the color, and whether it's available or not. So that is how we make use of what? Make use of a map. So these maps are very important in a way that we use them to do what? To communicate even with other programming languages. So now if we merge our knowledge of a list and a map, so you see this one, if I want to store another thing there, it will be hard for me. It will overwrite the other thing. I mean another variable. I mean it will overwrite the data of this particular one. So let's say that I create another structure of a map. Can just simply do like this to declare, to add value in a map. For example, that's what I wanted to show you. You can also add value in a map by doing like this, by just simply specifying the key and then go ahead and add the value there. All right, so I would like us to merge our knowledge of maps and keys. So I can say maybe product number 2 equals to, I go ahead and put the what? The product there. So after doing so, I can now, let's put our knowledge together of a list. So a list of our products will be like this: list of products. All right, so I can just simply declare my list by saying list is going to contain a map that is going to have, so here I'm saying a list is going to contain a map that is going to have string and dynamic. That's how I define my list. And then I go ahead and say products, I give it a name of a variable, equals to, and then I add there the first product and the second product. By doing like that, we shall be able to store both of these products in this particular list. So those are 3 products, those are 2 products. I can go ahead and add another product, say dot add. All right, so I go ahead and add. So when you're declaring a map, sometimes you might not need to first store it in a variable. So I can just simply open my curly bracket and close them, and then I go ahead and add the name, the what. So automatically it will know that is a what? It is a map. So we can go ahead and display products by looping. Display products by looping. So you see how we are putting now things together. So I can go ahead and display these products by looping through the what? By looping through the list. So now we can look through the list by just simply saying for, and then after saying for, and then we specify here the value that is going to receive the data. Of course, we know it's going to be a map and a what? And a map of a string and a dynamic and dynamic. and then you go ahead and put the variable that you'll use to access the data, and then you say in, and then you put products or the list that you want to loop through. So this one is going to loop as it keeps the data in this product. So you can access this product as you display everything like this. So that is the way how you can do it. You can display the product. Let me first comment these, and then you see how I've put the knowledge together. So by doing like this, shall have put our knowledge of what? Of creating single list with what? I mean, of creating lists and the maps together. So let me go ahead and run our class. I mean, sorry, our project. So you can see here we are having our first product. It is being stored in one particular what? In one particular variable. And then we have our second product, and then we have our third product. So there you'll have put the knowledge of a list and what, and of a list and maps together. So you can go ahead and practice more. So let's look at much more things. So you can define a map like this. I've already looked at that. And then here we are saying that you can even define a map in form of variable without specifying. Okay, you can define also a map by first declaring a map constructor like that. So let's look at most important things in a map. So you have what you call properties of a map. So you have a key. We have understood what's meant by a key. So a key will will help us to access a value in a specific position of a what? Of a map. Just like the way we had index or indices in what? In list. Then you have length. So length to tell us how big our map is or how small it is. It will tell us the size of a map. And then here is empty to tell whether our map is empty or it is not. So it is advised, like when you are going to loop, you might need first check something if it is empty or it is not before you do what? Before you do the actual looping. So we have another one, we call it, it's not empty. This method will tell us whether the map is empty or it is not empty. So let's look at commonly, these are properties. So when you call properties, you don't need to put a bracket on it. It is a property. You access it directly by just simply calling it. For example, if you want to know how long our map is, I can just simply say our map length. It can be, for example, let me come to this product. If I want to know its length, I can just say this dot what? Dot length. So like this, it will go ahead and give us the length of what? Of our map. So that is a property, not a method. So a method is the one that you'll call with what? With a bracket. For example, add all. This one will help us to add many things at once in a map. Clear. This one will clear all the data in the map. Remove. This one will delete a specific value in a specific position of what? Of a map. And then you have for each. For each will help us to loop in pairs of a what? Of a map. So let's say that you want to remove something from a map. You can just simply say this map dot what? Dot remove. So okay, like this. So you can say remove color. So it will go ahead and remove this particular what? This particular index or that particular key from the map. So I hope now, members, you can understand the difference between list and a map and why we may need these things in our programming progress. So I've looked at maps. We can proceed. To what? To functions. So functions, they help us to do what? They help us to create pieces of code at one time or at once, and we don't repeat ourselves. So they are very important. Like if I want to be displaying information of a student, I can create a function that is just responsible for displaying. So every time when I need to display that information, I don't need to write again that code. I just call the function, and then it will go ahead and do that task for me. So these are the steps that we take when defining a function. A function definition specifies what and how specific tasks would be done. So that is what we call defining a function. So it is when we write how tasks of that function should be done. Now we have calling. Calling is a calling is made when we are executing the function in that, the logic in that particular function. Or in simple terms, when we execute the function, that process of executing a function is what we call calling or call. So if I say call this function, I mean that it should make use of that function or execute it. Then returning means that you're returning something. A function is expecting you to process something and give something back. So that's what we call what? That's what we call returning. So we're going to look at all these. We're going to look at all these examples. Then we have parameters. So parameters are the values that we give to what? To a function to start with. For example, if we create a function that will be displaying a name, so it means that this function will be expecting you to give it a name that it should display. So that name that you give to a function that should display, that name or that value that you give to it that you want that function to use, that value is what you call a what? A parameter. So going to so in that we have optional position parameters. Here we can define whether a parameter should be passed or not. And then you have named parameters. Here we are defining how the parameters should be passed by use of what? Of curly bracket. We shall look at this. Is also very important. And then you have option parameter with default values. You define and then specify the values or the values of parameter by default. So if someone doesn't pass parameter, still it is okay. You can use the default one. So we shall see how we do that. All right, so let's go ahead and demonstrate our functions. Okay, so let's go ahead and create another file. I'm going to call it number 11.functions.dat. So this one is we're going to use this one to demonstrate what? To demonstrate functions. So I can run it. I say dart and then put like that. So you see it is not going to show anything because I'm not written there anything. All right, so you remember we have been using main. So main is a function that is called when our program is about to do what? Is about to be executed. Okay, now let's go ahead and create our functions. Okay, let's go ahead and create our functions. So a function, since this main is a function, so you cannot put a function inside it. So a function has to be outside. So let's go ahead and say, first of all, let me first define here the different functions that we're going to look at. We're going to look at a function with no parameter, and then we shall also look at a function with parameter, and then we shall look at the function with parameters and returning value, and then we shall look at the function no parameter and but returning value. All right, so we're going to look at those 4 main examples. They should be able to make you understand how you can get started with what? With functions. So we're going to create our very function here. So I can go ahead, for example, and say maybe a function should greet someone. Okay, so to define a function, you just simply write the name of the function. For example, greet. So it will be greeting. The use of this function, its task will be greeting. So you can say, in this function I can write greet and say hello. So hello, how are you? So that's the use of this function. That is its task. So if I want to display hello, how are you, 100 times, I don't need to do what? I don't need to write it 100 times. I can write it only one time there, and then I be calling it every time I want. So let's go ahead and display. So if I want to execute this function, I can go ahead and call it. So what I was doing, it was defining. All right. So now in this process, I come here to main function. We know that our program starts executing from main. So it will go ahead and call the main. We'll go ahead and call the main. So the main will be executed. So that's what we call calling. And then when it runs, we call it executing. So let's go ahead and run this file. So I'll open my terminal and then come and call that function. So you can see, hello, hi. This function is not taking any Is not taking any parameter. It is just used to, we are using it just to do what? To process something and display. So I'm not using it to take parameter, to take values. All right. So that's one type of a function. So let's look at another type of a function. This type of a function, it will take some parameters. For example, we can call it say my name. All right. So display name. All right. So it will be taking the name that you want it to display. So I can say display name. Now the function that takes parameter, you specify that parameter in the bracket on top. So I can just say this function is going to expect you to give it a what? To give it a string. And then when it finishes, it will, when it starts operating, it will go ahead and display that string. So it means that this function will receive some data. So that's how we do it in that. So let me go ahead and display, for example, the function. I can just simply say print, and then I go ahead and put there the what? My name. All right, I can say Muhindo Baraka, something like that. So if I run it, it means that it will receive this. Sorry, I want to call this guy display name. Okay, it will receive this name, and after receiving it, it will go ahead and display it here like this. All right, so let's go ahead and do it. Let's go ahead and display it. And run the file. So if I run it, you'll see that it is able to do what? To display my name. So that is the function that takes one parameter. So, and that's how we do it. You define the parameter, and then you go ahead, and when you receive it, you go ahead and what? And make use of it. Okay, so what does it mean here? It means that we can write our functions in one place, and then we make use of them even in multiple places, as well as in multiple projects. All right, so let's proceed. A function can receive more than one parameters. For example, let's go ahead and demonstrate a function that receives more than one parameter. Function that receives two parameters. Okay, so to do so, we can have a function that can be adding two numbers. All right, so we can have a function that will be adding two numbers. So it means that I'll go ahead just a second members. Hello. Alaikum salam wa rahmatullahi wa barakatuh. Okay, just got some good news. Okay, so we can go ahead and create a function that receives more than one value. For example, we can create a function that adds two values. Members, I hope you're following, because I'm going to ask you some questions after this example. Add two values. All right. So we go ahead and say, and we put what it should receive. So it will go ahead and receive the first value and the second value. All right. So let's go ahead and print them. We shall just simply go ahead and display them by saying print. Let's first display what we are going to add. We say print, and then you put you go ahead and put what? You go ahead and put A, and then I go ahead and put plus, I go ahead and put what? And put B equals. So let's go ahead and create here our int called C, and we're going to make it A plus B. So you can just simply say plus B equals to C. So let's go ahead and display it here by doing like this. Alright, so we close. So this function, it will receive two values and then go ahead and add them and then display the answers. Alright, so I hope you can see that. So let's go ahead and do that. So let's go ahead and call this function. So you can just simply call this function by just simply calling the function and then give it the values. For example, I can give it 4 and what? Comma and 8. So that's how multiple values are passed to a function. Multiple values. So I can save and then go ahead and run this file, and then you shall be able to see that it's supposed to be A. Sorry, I have to put a plus. Yep. So let's run it. So you see A plus B equals to 12. So here the whole point is we are writing the logic only one time, but we can use it as many as we want. Okay, so you can have a function that has like 50 lines of code, and you write it only one time. You just be calling it to do for you the what? The job. So that's how we define functions in Flutter. In Dart programming. Let's look at two more examples. Functions that return things. Okay. So sometimes you may need to add two numbers and not display them. Maybe use them for something else. So by that way, you can go ahead and make the function to return a value. All right. So you can say a function that sorts what? Maybe that multiplies two numbers and give you the answer. All right. So you can be using this answer for something else, maybe to save in the database or to process something without displaying. So that kind of function is a function that that returns. So you need that function when you want. So you need to return when you make use of that kind of a function. So let's go ahead and create this function, and we see. So I can say so a function that returns, we have to promise what we want to return. So let's say that we want to divide two numbers and give the answer. So there we have promised that we're going to return a double because we expect even some decimal points. So let's say that you want to add two numbers and give the answer, something like that. So you have to specify what you want to give as an output of this function. So I can say my function is going to be giving the answers of two numbers that have been multiplied. Okay, of two integers that have been multiplied. So by doing so, it means that we are going to expect it to bring back the integer. So by doing so, I call it promising. So I promise first that I'll return an integer, and then create now the function. I say multiplier, okay, and it's going to be taking two values. It's going to be taking integer 1 and it's going to be taking int I say x and int y. So if I press enter, so you'll see that this one is still is still complaining. So it is complaining because I've not performed the real thing. So I can go ahead and define here my other integer and call it z equals to x times y, and then I go ahead and return. So this is what we call returning. So you're returning, whoever calls you, you give them the answer. So the difference between this function and this one displays, does not return, but this one is processing things and gives you the response. So let's say that you want to multiply two values. So let me first comment this one. I can say, for example, the results of which is going to be integer, result equals to multiply. and then I give a value and I give values, and then I can go ahead, for example, and display the results. So what does it mean here? That we can use this value to do other things, not necessarily displaying. So that's the advantage of functions that do what? That do return. So you see, this function is returning the values. So that is how we implement returning what? Returning function. Okay, so that's how we implement what? Functions that return. So it did multiply this, and then got the answer, and it saved it in values, and then after we display the answer. Members, I hope you're following. I hope you're understanding. I'm going to ask you questions after the first session, so all of you be ready and be attentive. So let's go to another function. We shall go ahead and now get started with what? With object-oriented programming. But before we go to object-oriented programming, I'd like to show you advanced way of how I can deal functions. So we have what we call variable types. So a variable can be a global variable and a local variable. So let's go ahead and look at that. Let me create another file. It's going to be number 12. So you can say maybe function access. How you can access different values in a function. Before we go to, so in the next session, we are going to start We're going to start object-oriented programming in Dart. So we shall finish that in the next lecture. In the next session. Then in the next lecture, we go now direct to Flutter programming. We start doing now mobile applications. So be very attentive. These things are important. Let me remove all these. So now let's say that the accessibility. So you know that you can declare here. So this is our main function. It is starting from here and it is ending from here. Now let's go ahead and declare, for example, a name and say John Black. Okay, so this name is, this variable is outside all functions. Now I want to create here our function 1. All right, and I want here to create our function 2. Now I want us to call the first function. All right, so if I go ahead and print, run the project, you'll see that we have got the first function. Now, what if we want to access this value of a name? So I can just simply go ahead and say, let me just put here the name hello, the name from function 1. All right, so you see we can access this global variable. So this item that is outside the function, we call it global variable. Can go ahead and say name 2. All right, so if I go ahead and run our project, you see that we're able to access the variable. Now, what if we have a string called name equals to baby cool? Okay, so now the question comes, what is this one going to print? Is this going to print this name? It's going to print this global variable. So of course it's going to print the variable, the local variable. So you see, it is printing the local variable. So does it mean that this name has changed? Let's go ahead and call function 2 and see if this name was really changed, the first one. So if I go ahead and call it, so you see, the first name did not change. John Black is still there. So it means that this one was just a new variable. But if you don't specify it, it will go ahead and do it. So now what if I remove string? Okay, is it going to change this one? Let's go ahead and run it. So you see, it is going to change it. So in Flutter, that is how you access global variables. You don't need to specify anything, just access it and manipulate it. So the next thing that I'm going to use it, they'll find it what has been what? It has been used. Okay, or it has been updated. So you see that here we override it. Then means that if we call the function 2 after this one, it will have changed the variable. So that is how we change variables. So in the next lecture, in the next session, we are going to go now to object-oriented programming, how we define classes, etc. And then after, if time allows, we shall get introduction to Flutter itself. So I would like to hear some questions from you members, if there is any. If there is no, I'll ask you. Can I get 2 questions, if there is any? All right, then let me ask, then before we have our break.
Sir,
yes.
I beg your pardon on maps. I didn't click them very well.
Maps. So, all right, I'll maybe answer it orally. So maps, they help us to store data of different structures in a single variable. So I can have a map of a person. So a map of a person, I can define many things about a person and I keep them in one variable. But the advantage is the variables, let me come like this. A map helps us to store data of different structures in organized way or in a particular variable by the use of a key and a value. Let's say that Gertrude, for example, you want to store the information about books. So what you can do, you can first accept on the structure that you're going to use. A book should have a name, a book should have an author, a book should have a price, and maybe the year when it was manufactured, when it was written, okay? So that is the structure of your books, okay? So you have like 20 books. So it means that when you're going to keep these books in the different data type, in the right data type that will be there for you to keep that structure of books in Flutter or in that programming. Instead of you defining the book name separately, and then you define the author name separately, and you define this separately, why don't you use a map where you say a name is stored here, a what is stored here, and then you put them in one variable. So if you want to access, you can go ahead and use what we call keys. For example, you just go where there is a name and get the name of that book. Now, to make it interesting, you can since you have many books, you can go ahead and use what we call list, as we demonstrated. So this can be, for example, your book 1, and it is having this kind of a data. So you see, it is this is what we call a map. It is being defined by a strings followed, what we call keys, followed by another different data type, which you call the values. So like this, that's what you call a map. So you can use it to structure your things. Assume that you didn't have this map. So how would you store these things? How would you know that this is the name, this is the price? So a map gives you a better way to define a key by use of string and then store anything in there. So I can even go ahead and define and map inside another map. So since it is dynamic, it means I can go ahead and put there another data type. So if it is limited to string, for example here, it is limited to strings. If we put here string, so it's going to give us an error. Why? Because we're going to expect the values to be only string. So if I come here, if I leave it as dynamic, I can go ahead and put here, comma, and then I put, for example, available in shops. Okay, so I can put here another key, you see, and then say shops, all the shops that are available. All right, shops that are available. So I can go ahead and define here a list. So a list, we define it by square bracket, if you still remember. So I can put a map inside this list. Okay, I go ahead and say shop number 1. Okay, shop number 1. So it has a name, which is shop 1, and then the location is in Kampala. I can go ahead and put there a contact, you see. So we are able to define, let me show you. So I put a comma there, it will go ahead. So you see this, so our shops, it's available in, I go ahead and open a square bracket. Square bracket will lead us to a list, something that will store more than one. And then say that's a square bracket. I put another map, which is going to be a curly bracket. Okay, I go ahead and put it through the first shop, shop 1. Okay, name of a shop is called shop 1. Location is in Kampala. Name of a shop, shop 2. Location is in Kigali. I can go ahead and add there another shop. Shop number 3 is in Nairobi. You see? So this is a map that is giving you the ability to store different data structures into one what? Into one variable. I mean different structure of data into one variable. So that's what you mean by map. So when you practice, you'll definitely understand. I hope I've answered your question. I hope you've got more light about it.
Thank you, sir.
All right. Okay, let's breathe for 3 minutes. So 23 past, we should be back and we start our second session. All right, Derek, ask. Yes, Derek.
Excuse me, sir. I've been going through some documentation and I found some. I had the concepts to understand about functions. The first one was the difference between a mandatory parameter and a null pointer check on a parameter. Does it mean that if I put a null pointer check on a parameter of a function, every time I call that function, it shouldn't be, the parameter I'm passing shouldn't be empty, shouldn't be null? Or is it the same thing that means that that parameter should be a mandatory, should have a mandatory value by default?
All right, thank you for reading ahead, Mr. Aheva. That's what I would like everyone to do. Now, if you go deep, you'll find that is very interesting programming language, very interesting compared to other languages. When you're defining functions, you can define them in 2 ways. You can say some parameters should be compulsory, some should not be compulsory, some should have default values, some should not. Let's go ahead and do one example about this. So I can go ahead and say, let me give an example of the contact. Okay, so let's say that we are creating a function, a system that will be saving contacts of people. So we go ahead, that's a good example. So we're going to create a function called save contact. So in this function, we can say maybe, okay, display contact or save contact. Save contact. So this function is going to be accepting different values. So I did not go up to this far. So you can open curly bracket like this and go ahead and define things that you want. So I can go ahead, so I'll show you that. So I can define and say, you must provide us a name. Okay? All right, let's do it like this. You must provide us a first name. So if you say that you must provide us a first name, you put the word required string and then for example you can put first name. Okay, so must provide us a first name in order to save your contact. But you can say maybe the second name is optional. Okay, the second name is optional. So to say the second name is optional, in this case you go ahead and define last name. Okay, so you can remove this string to make it optional. So if you make it optional, it should be having a default value. Okay, it should be having a default value, or it should be nullable. Okay, so to make it nullable, so there are two ways. If you want to make it optional, you can either give it a default value or you can make it nullable. To make it nullable, you just simply put question mark here. So if you put a question mark before defining a variable, it means that that value can possibly be null. It will either be a string or null. Another way, for example, other name, we can say other name. Other name. You want to make it optional. You can just simply remove this question mark and put a what? And put this default value. It can be an empty string, or you can put, for example, no what? No other name. Something like that. So it will be up to you. Then I can say the phone number is required. The email can be nullable and whatever can be nullable. So it will be to you now when you're doing the logic of saving, okay? Doing the logic of saving, okay? So it will be up to you to say, hey, I know first name is required. So when you're saving, okay, when you're saving, you just simply say, for example, let's say that you want to save now the data, maybe data to be saved. So I can just simply put here, for example, my map of string, comma, dynamic. Okay, and I say maybe data to be saved. Okay, this is the data. For example, now this is the data to be saved. Can go ahead and define it as an empty data structure.
Recording in progress.
Members, sorry, my Wi-Fi was not in the data. I mean, sorry, it was not in electricity. It was not charging all along. So the battery just went off, but I'll put it back. I hope can you hear me? Members, can you?
Yeah.
All right. So I was explaining your question. So now let's say that we are now saving the data. All right. So it will be up to you to do the logic now. So I can say that the name will always be saved. I mean, the name will always be provided. So I can just simply put here and say first name will always be provided. So I can just say first name equals to first name that was provided. All right. Now I can do the logic. I say if you don't give us a last name, I should put there no last name. So I can just simply say if this is equal to what? Is equal to null. I go ahead and put there what? And say now last name should be no last name. Else, all right, else last name equals to this. All right, last name equals to the last name that was provided. So what does it mean? If someone does not provide us a last name, we can decide to put there no last name. Okay, like that. So let's say that you see this dynamic. The advantage of dynamic is that it can store what? It can store a null value. All right. However, you can, if you want to limit, let's say for example, if I say email, I just simply say email address, email equal to the email, like this. All right. So that is okay. Why? Because this is dynamic. To accept if it is null or not null. So if you want to make our thing to be strict, I can just simply come here and put the what? String. So it should be string. String cannot be null. So if I make it string, I'm going to make here, I'm going to get here what? A warning. I wanted this one to be first name, not last name. I'm going to get a warning here. I'm going to get a warning. Why? I'm trying to save something that can possibly be null. I'm trying to save it in a what? In a string. So it will give me a warning. So how can I get rid of this warning? I can first check if it is not null, then go ahead and do so. You can do it in line, for example, you see this one. It is not crying, this one. Yet it can possibly be null. It is not crying. Why? Because we have checked it. If it is not null, then it should execute. Others, if we put it outside here, it will also cry. It will also give a warning. Okay? So I can get rid of this one by checking either by using if condition. I say if this guy is not null, if is not what? Is not null, then go ahead and save it. If it is not null, then that is one way. We can also do like this. You can just simply put here question. If it is not, so you can just simply put here if equals to null and then put question and then do what will do what in case it is null. Else we put here else and put here like this. So that is how we do ternary operations. You just simply check if this guy is null. You should do this. I can put here, for example, no email. Else you should save the email. So that is how you can do this. So when you're calling this function, I'll just simply call it like this. So those who didn't know the advantages of specifying parameters, so things that are required, they will need to be provided first. All right. So for example, first name. So this function, when we'll be calling it, that's how we shall be specifying the parameters, by giving the name. For example, first name, I can put Eddie Kenzo. For example, Eddie, first name. Okay, so it is still complaining. Why? Because we are still required with the phone number. Okay, so I can put phone. I go ahead and put the what? The phone number of Eddie Kenzo. So those who don't have it, you can write it. So that is his phone number. All right, so you see, that is it. So when we stop providing, if you want your things to be organized in structure, you can put the comma at the end, and it will be in this way. So if we stop providing at the name, at the phone, the warning will do what? Will stop, because we have provided the two things that are required. However, you can go ahead and provide more things, for like last name, and put, for example, like this. Okay, so the order does not matter. So I hope I've answered your question very well.
Yeah, question answered.
Okay, you have understood, eh?
Yes. I have a question.
Yes, please.
Is it necessary to like put the parameter name when you are passing on the value?
No, it's not necessary. I've demonstrated where we do not specify. So there are two ways of how you can define. So you see this one, f1. Why didn't you ask me that? Oh, sorry, this function that we demonstrated here. You see, we did not specify here the name. When we called this one, did we specify a name? No.
No.
But the order matters. So if you don't specify the names, the order will matter. If you specify the name, the order will not matter. So how do you make a function that will accept things to be specified by names? You do it like this. You put curl bracket when you're defining it. So if we want to display the name, for example, a function that displays the name, dp name, so I can say dp name. So if I want the other person the person who will call this function to specify the name, if I want him to specify the name, I'll just simply come here and do like this. Put curl bracket, that's the whole difference. And say you must specify the name. Alright, specify the name. I say a name will be what? It will be a string specified like this. So if I want it to be required, I can just simply say required like this. Required string of a name. So it means that when someone will be calling this, he must specify the what? The name. Okay, so we'll just simply put here name and put John Doe, something like that. So if I say dp name 2, I can go ahead and still call it. I'm saying I just want a string that I'll call a name here. So the one who will be calling this dp name 2, he will not need to specify the what? The name. You can just simply say Peter Miles like this. So did you understand?
Yes, sir.
All right. More questions? Are there more questions, members? All right, if there are no more questions, let's drink water for 3 minutes. So 20 minutes to 4, we shall come back for the last session. We are going to look at object-oriented programming in that. Let me put here the counter so we can all be watching.